in this video, I'll be teaching you what the intermediate value theorem is. So let's just explain what it is step by step. Let's say there's a function with an interval, with a domain, from -5 to 5. And the endpoints of a function, but within this domain, is -5, 3 and -5, 1. Sorry, 5, 1, not -5, 1. Now that we have these 2 points, we have the y values. So the y values of the 2 points are 3 and 1, correct? That means that there must be a point along this graph, as long as it is continuous, or this function, as long as it is continuous, where the y value is equal to 2. Or any number for that matter between the 2 endpoints y values. So there must be a point in this graph that has a y value of 2, 2.5, 1.3, 1.0001. Now, what do I mean by this? Well, if we draw any function, let's draw anything. Okay, that's not a real function. Draw any function like this. There must be a point that has a y value of 2. Remember what I said about that? So it must be a point that has a y value of 2. Well, as long as this function is continuous, well, maybe y value of 2 is here along this function, or maybe it's somewhere here. Correct? But it's impossible to draw a continuous function with these 2 endpoints without having the value 2 in it. So, think in your head. Try to draw a function in your head where it doesn't have the value 2 in it. It's absolutely impossible. You can go up and above, and all the way down. But guess what? Although this beginning half didn't have a value of 2, it went up. Now it must have a value of 2 as it goes down to reach 1. So the intermediate values theorem kind of states something intuitively obvious, but it's not something you really thought about until you did it. And why is this useful? Well, this is useful because let's say you had a function. So let's erase these old points. Let's say you had a function where the 2 endpoints of the function are on opposite sides of your y axes. So this is -5, -2, and this is 5, 1, 5, 3, let's say, since this is pretty high up. There must be a point, as long as there's a function that's continuous, where the y value is equal to 0. So this point, this entire function, as long as it's continuous, it follows the intermediate value theorem, and it must cross the x-axis. Therefore, it must have a y value of 0 in order for the 2 endpoints to reach each other. And if I'm being more clear, there must be a value for every single y value between your 2 y values. So this y the values here are -2 and 3. So between -2 and 3, there must be a y value along this entire graph for every single value possible between -2 and 3. So it could be 2.1. Maybe 2.1 is, I don't know, right here. This is 2.1, has a y value of 2.1. It could be -1.0001. Maybe that's right here. All right. It just has to, as long as the function is continuous, have a y value for every single point between y value between the 2 range boundaries of your endpoints. So if a number on an endpoint is negative, right here, negative, and if a number on another endpoint is positive for the y values, that means it must cross the x-axis in order to reach the other endpoint. So the function must cross the x-axis as long as it is continuous. Therefore, it follows the intermediate value theorem. So hopefully that was a decent enough explanation for you guys. But, of course, if you have any questions, leave it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.